Hello and welcome back. In this video, we are going to uh, learn how to implement in Python for the same problem, and the problem is merging two sorted arrays. Okay, let's get started. I am going to first let's why don't we just see the problem? If you just happen to see this video without seeing the Java implementation, then probably it's good to see the you know the problem statement itself. So here is the problem. Given two sorted integer arrays, nums1 and nums2, merge nums2 into nums1 as one sorted array, and there are a few things given. We just remember this notation. The number of elements in nums1, the first array m, and the second array nums2 is n. And then we also assume that nums1 has enough space for us to accommodate all the elements of nums2. We have some sample data here, that's what we're going to use. And solution approach is we have steps here. Okay, first we get pointers for nums1 and nums2, the last element basically, because we are going to start from the end. And then we get the insertion pointer, which is different from the last element element of interest actually. For example, if you see it here, 12 is our last element. We inserted those 5 zeros to accommodate, to create a space for elements of nums2 over here, right? So our insertion point is going to be this one, first insertion point, whereas our last element is going to be this one, the 12, right? So clearly the indices are different there. And then we do something in a loop. That is, we compare, as long as there are elements, some elements left in both the arrays, we compare the elements, and whichever is bigger, we inserted the last index. In the net for the smaller one, we compare with another element of another array, and then whichever is bigger again goes to the second last, right? And we continue until both the arrays have at least one element. Okay, and then there might be something left that will be covered by doing the array copy, right? And then this solution has time complexity of order of m plus n, and space complexity of order of 1. And I have here some sample array declaration in both Java and Python, so that we can just copy paste them. It's easy. I'm just keeping data handy here. Okay, so that we can minimize the total time required for video, because some of the websites or the platforms, they have limitation on the size of the video, so that's what I'm trying to minimize. All right, let's minimize this and get started with our program. All right. Okay, so I am going to start my file, merge sorted array. I think that was the name in Java as well, and this time it's going to be, instead of AVA, it's going to be py. Okay, all right, let's just define merge method. It's easy, very easy. Okay, nums1 m nums2 n, that's it, and I get a pointer, right, is equal to n minus 1, and p2 is equal to n minus 1. Okay, and then in my insertion pointer is going to be m plus n minus 1. Now what do I now I do the comparison. Okay, while p1, that means while I still have elements left greater than or equal to 0, and p2 still has, sorry, nums2 still has at least one element left, I do some comparison. So what do I do? That is, if I check the elements, nums1 p1 is less than nums2 p2. Okay, nums2 p2 is bigger, so that's why in my insertion, using my insertion pointer, I'm going to insert the num1 because I need to merge there, right? And that's going to be my index, right? In Java we did p minus minus, but Python doesn't have that one, so we're going to write one more statement. So what I'm going to assign, the bigger one is nums2 p2. Okay, and I need to decrease the counter p2. That's the p2 is equal to p2 minus 1. That's p2 minus is equal to 1 is equivalent to p2 is equal to p2 minus 1. Okay, and then otherwise, what do I do? Otherwise, bigger one is nums1 p1. So I'm going to assign nums1 p in my insertion place. This one, the bigger one, nums1 p1. Okay, that's and then I need to decrease the counter because this time my p1 is I process my p1, right? That's what I moved. So p2's counter will not be should not be decreased, and because it did not enter into the if block, it entered into the else block. So if it enter here, which is bigger, I'm going to decrease that counter because I already consume one element, right, from my total number of elements. And then I have to decrease the counter for the p also, and that counter I need to do it in both the cases, whether I get element from nums1 or nums2. I decrease my space by 1, right? So I have to decrease the counter. Okay, so and then for the remaining elements, I have like in Java, in Python also we can copy certain elements of array. For Python it's different syntax, a pretty interesting syntax. Look at this one. I can do this one. See, very interesting. Nums2 and here p2 plus 1. It's pretty interesting. You see, I'm going to store in this nums1. Okay, so p2 plus 1 is the index from 0, because if I don't write anything before the colon, it takes from 0 to p2 minus 1. p2 plus 1. Okay, 0 to p2 plus 1. Let me have a line number here. In line number 15, 0 to p2 plus 1, and then I get those elements from nums2. Okay, and here also 0 to p2 plus 1. Okay, that's the range, because those are the ones that will be left if those are not covered by the while loop. Okay, that's because those are the smaller one will be left. Actually, that's why we are inserting from the 0. Okay, since we start from the n and it's sorted array, larger one are consumed first, anything left comes to the beginning of the array. Okay, so our main logic is already implemented pretty fast, pretty interesting, and now we're going to do our main. Okay, main main method implementation, or main function I should say, in if I'm writing Python, because I don't have a class here in order to have method, but whether it's method or function from algorithm implementation point of view, probably it's going to be the same logic, same thing. Okay, it doesn't really make a difference, so no worries on that. Now let's get that array. Actually, no, let's save some typing over there. Right, minimize that, and let's just paste it over here. Okay, that's fair, and that's fair because all right, and then shift that. Okay, all right, we have two arrays ready. So I'm not going to calculate the length, I'm just going to call the method merge. Okay, and I'm going to pass my nums1, right, and then length is going to be 4, nums2, and its length is going to be 5. Okay, I will call that method, do all the processing, change the content of nums1, we're ready. Those things will be ready, and I print my nums1. Like in Java, I don't have to, I should say, unlike in Java, I didn't have to write a for loop and then print element one by one. Here I say print nums1. In Python it understands and print all the elements of this array. Okay, that's a done deal, fast, pretty fast. I need to do one more thing. So if you remember, that's going to be this line. Let's just remember this one. If name is equal to main, then I'm going to call main method. Okay, that's it. All right, we're done. Let's apply this to my Python interpreter. Python interpreter. let's see how many errors. Oh, no errors, one shot, very good. 37, 8, 10, 11, 12, 15, 18, 19, and let's check whether that's exactly what we wanted. And that's exactly what you wanted. Okay, 19, 18, 19, 37, 8, 10, 11, 12, 15, 18, 19. Okay, very good. So in one shot, it went in one shot this time. So this completes Python implementation of um, of the problem of merging two sorted arrays. Okay, so this completes our solution, both Python as well as Java, which is Java in previous video. Our complete solution for this particular problem of merging two sorted arrays. I will see you in another video for another problem.